The original A7s were powered by the Pratt & Whitney TF-30 turbofan. They were equipped with multi-mode radar, and the airplane armament was one 20mm M61 multi-barrel cannon, plus up to 15,000 pounds of mixed stores carried externally on 6 under-wing stores pylons. The TF-30 engine would give the plane a top speed of 570 mph at sea level. Specifically in line with the Navy requirements for ease of maintenance, this engine had only 42 steps in the installation procedure, and this could be achieved by a well-trained crew in under 15 minutes. All of this was precisely fitted into a specifically built airframe for the Navy's light attack role. The A7 first flew on September 27, 1965, 4 weeks ahead of schedule, and was adopted by the Air Force and Navy. Vought was once again making Navy planes at full speed. A7 production eventually totaled more than 1,500, including exports, when completed in 1982. The initial carrier trials showed some limitations. During the catapult launch, the steam from the catapult could be sucked into the engine intake, reducing the thrust provided by the TF-30 engine. To overcome this, limitations were placed on takeoff weights of the A9As until the power plants were upgraded. In spite of the engine limitations, the Corsair was needed for the Vietnam conflict. Later, the same squadron, VA-147, also were called to the waters of North Korea. This squadron would fly their Corsairs for almost 20 years, and they were only replaced by F-18 Hornets in 1985. These were, for the time, the best light attack aircraft ever produced. On takeoff and landing, the XF-8U's wing could be pivoted up 7 degrees, hinging on the rear wing spar and jacked up by a hydraulic actuator. The variable incident scheme allowed the wing to assume a high angle of attack, reducing the approach and takeoff speed while keeping the fuselage level and providing the pilot with good visibility. In addition, the raised wing centre section acted like an air brake, reducing landing speed further. The airframe's concept was designed with the new area ruling scheme, in which transonic performance was improved by making sure all cross-sections of the airframe changed as gradually as possible. This provided minimum drag at above the speed of sound. Many of the concepts proven on this aircraft are still standard on today's fighter planes. Today, the Crusader has a reputation that is hard to beat. It had outstanding manoeuvrability, excellent performance, and a very powerful attack. The armament section contained 4 20mm cannon with 144 rounds per gun. Behind the guns on each side of the aircraft was a launch rail for a single Sidewinder anti-aircraft missile. The aircraft was also fitted with a retractable rocket pack in the belly that stored 32 70mm unguided folding fin rockets. Later versions were strongly enhanced for the strike role through target illumination radar and the addition of 2 removable underwing stores pylons for jettisonable Zuni rocket packs, or up to 5,000 pounds of unguided weapons. Though nearly half the fuselage was occupied by the large Pratt & Whitney J57 engine, the airframe's design would allow for long unrefueled flights. Another innovation was the RAT, Ram Air Turbine, that could be extended from the right side of the fuselage directly behind the cannon for emergency electrical and hydraulic power. The RAT would prove very useful in practice, allowing many pilots to bring home aircraft that would have otherwise been lost. The basic airframe would appear in 18 production versions and hold many world records. Variants included reconnaissance, photographic, night fighter and twin-seat trainer versions. Future astronaut John Glenn broke the transcontinental speed record for the 2,445-mile trip between New York and Los Angeles in a Crusader on July 16, 1957. Over their lifetime, 1,263 Crusaders were built. As a mark of their abilities, their redesigns ran for over 10 years, while most of their contemporaries were simply junked at the end of their service lives as obsolete. In the 1960s, several hundred F-8Us were remanufactured to extend their service life. Up until 1986, US reserve units used them, and a small number were built for the French Navy. The final flights of these French Crusaders occurred at the aircraft's retirement ceremonies in Brest, France, in December of 1999. The Thunderbolt was the most famous of the Republic Aircraft Company's planes they built during World War II. It was first flown on the 6th of May 1941. The P-47 was designed as a large high-performance fighter bomber. The power plant was the large Pratt & Whitney R-28 Double Wasp. At the time, many aircraft manufacturers were moving toward inline water-cooled engines, as applied to the Mustang, but Republic decided to stay with the proven and tough radial engine. This would prove to be a wise decision, as the later Mustang with its inline engine and the P-47 with its radial engine ended up complementing each other. Like the Mustang, the first P-47s were Razorbacks, and the pilot complaint was rear visibility. Pilots did not know an enemy was tracking them until they were shot at. Again, like the Mustang, a bubble-type canopy was fitted to later models that gave pilots excellent visibility. The Pratt & Whitney R2800 18-cylinder air-cooled radial engine created over 2,000 horsepower and gave the P-47 excellent performance with a large load carrying capacity. The first deliveries of the P-47 took place in June 1942, and the US Army Air Corps began flying it in the European theatre. Although it was an excellent airplane, several improvements were made as production continued. Each improvement added power, manoeuvrability and range. As the war progressed, the Thunderbolt, or Jug, as it was affectionately called, gained a reputation as a reliable and extremely tough airplane, able to take incredible amounts of damage and still return its pilot home safely. The only vulnerable place on the P-47 was the position of the fuel tank. It was located right under the pilot's seat. If it was hit, the pilot had to be quick to get out. The P-47 was twice as heavy as any other fighter before it. Most of the extra weight was due to the extensive armour plating incorporated into the body of the plane. Not only was the plane difficult to shoot down, it packed a lethal sting. It had 8 50-caliber Browning wing-mounted machine guns and could carry 2,500 pounds of externally mounted bombs, rockets, or other free-fall ordnance. Even though it was heavy, the P-47 had a maximum speed of 433 miles per hour, which made it the fastest fighter in service. It had a ceiling of 41,000 feet and was equally at home in high-altitude dogfights or low-level ground attack. Apart from the European theatre, Sovietsky's P-47 were put into service in the Pacific. There they flew ground attack and support missions. The Battle of the Marianas was one of their most celebrated missions. In late May 1944, P-47s of the 318th Fighter Group were being prepared for battle. From Pearl Harbor, they were loaded onto carriers and stored for their sea journey to Marianas. The P-47s would not be flown in the initial air combat. They were not carrier craft and would not be able to take a carrier landing. They would only make one carrier takeoff. At the same time, the sea fleet that would lead the assault was also readied. An engineering group was dispatched as well. If the invasion was successful, the engineers would be needed to repair the Japanese runways for use by the P-47s. The invasion of the Marianas was a major step forward for the Allies, and if successful, the Allies would complete the blockade of Japan, cutting off their war supplies, including the much-needed rubber and oil. In fact, the Battle of the Marianas would be Japan's defeat. They simply would not be able to operate without the control of this tiny group of islands. The three important islands were Saipan, Tinian and Guam, as they had airfields. The Allies needed to capture at least one of these and then begin the operation of the P-47s to attain air superiority over the region. The first to fall was Saipan's Aslito airfield, and the engineers immediately started repairing the runway. Littering the airfield were the wrecks of Japanese planes. A total loss of 420 planes was inflicted on the Japanese in this battle, and it was a loss that they would not recover. When the runway was repaired, the P-47s were flown in from the carriers to the strip. They left at a rate of 1 every 2 minutes, and none were lost. The new strip was renamed Bisley, and this would be the new home for the 318th Fighter Group. The Japanese, although evicted from the airfield, still put up a tremendous fight to prevent the Allies from using it. No sooner had the first P-47s landed, they were armed and sent straight into battle. By nightfall, they had already carried out several missions. The Thunderbolts were an important part of winning the Saipan, Tinian and Guam campaigns. On Saipan alone, over 26,000 Japanese lives were lost. The Battle of the Marianas was the last time the Japanese could engage any real sea defence or attack, and their air force was becoming very depleted of both planes and pilots. The production run of the P-47 ended in December 1945, and over 15,500 were built, which makes it one of the most prolifically produced fighter aircraft in history. Technology was growing rapidly, and the day of the propeller fighter was ending just as fast. However, the USAF retained some P-47s until 1949, and the US Air National Guard maintained a small number until 1953. Others were paid out to many Latin American air forces that operated them through the 1950s. Peru used the P-47 until 1969. Like all of the famous World War II fighters, by the time the war ended, they had their day as the jet age was emerging. This early GR model Harrier is performing a world first. It is landing on a ship's helipad. Never before had a jet fighter landed on such a small platform in the middle of the sea. This feat was done while the ship was rolling at 12 degrees, and the wind was blowing at 35 knots, and the ship's superstructure caused severe turbulence. Regardless of the conditions, the Harrier was easily able to make repeated vertical landings and takeoffs. Some say the Harrier's only downfall was its inability to go supersonic. The operation of the Harrier is reasonably simple. In the cockpit, 2 levers protrude from a rectangular box. One lever is the throttle and the other is the nozzle angle selector. The position of the controls is such that the pilot doesn't need to look down to operate the levers. For forward propulsion, the throttle lever is simply pushed forward with the nozzle selector. For a short takeoff, throttle and nozzle selectors have a preset position. The nozzles are angled at 55 degrees. Hover or VTO is achieved by pulling back the nozzle selector to the vertical position, which has a fixed stop. For braking, the lever is lifted and then shifted into the braking position. The pilot can go at any time during flight to maximum braking, which makes the Harrier a very difficult plane for conventional fighters to follow. This is a later version of the Harrier. It's the GR5. It can be visually identified by its longer wingspan. The wing, which was made by McDonnell Douglas, is carbon fibre and has the strength to carry 1.5 times as much fuel as the earlier Harriers. The GR5 has 11 weapon stations, which includes 4 under each wing. The plane's weapon load exceeds 9,000 pounds. The G5's testing proved the plane was a great improvement over the previous Harrier, but the biggest advancement was the ability of the plane to be able to carry twice the weapons load as the earlier model. The Harrier jump jet is one of the most unique aircraft ever built. It has been described as one of the smallest and most elusive fighters in the world. Another feature of the Harrier is it's very easy to hide. For countries that feel their airfields are vulnerable, the Harrier is their choice of fighter. The Harrier, with all its great attributes, didn't achieve the recognition it deserved. It did not sell as well as it probably should have, even though it proved itself as an outstanding success in the Falklands War. It took some time to convince the British government of the Harrier's worth. However, they did finally place an order. It was expected that the Harrier would operate from the 2 British aircraft carriers, Ark Royal and Eagle. It was from the Eagle that the first sea flight trials were conducted. 2 Harriers were finally given the chance to prove their worth. All takeoffs were conventional, and even in this mode, the ship's catapult system wasn't required. Combat simulation was carried out with the planes fitted with inert munitions and extended fuel tanks. Landings were made with the ship at full steam and in reasonably rough conditions. The Harriers proved themselves as very versatile planes and competent combat capable. During 1971, the Harrier began service with the 1st Squadron of the US Marine Corps. The US designated the plane AV-8A. They were a similar version of the British plane, but they carried the AIM-9 Sidewinder air-to-air missile. The plane armed with a Sidewinder was ideal for rapid reaction air defence missions. Later, these planes were updated and equipped with the big Sea Eagle anti-ship missile. The Sea Harriers were also fitted with devastating 2-inch rockets. This is a demonstration of a training exercise on a towed target. These rockets could be launched 72 at a time from 2 pod launchers. This weapon was used extensively in the Falklands campaign. Launching 72 at a time gives several seconds of continuous firepower and coverage. The rockets were very accurate. The Sea Harrier also carried the short to medium version of the Sidewinder air-to-air missile. The missile could dispatch an enemy at a range of about 8 miles. Toss bombing or horizontal laydown bombing was also possible with the Sea Harrier. The Harrier's known service record consists of action in the Falklands, Desert Storm, Bosnia, Afghanistan, and most recently in Iraq. But it is gradually being phased out as the JSF-35 comes closer to entering service. Nonetheless, the Harrier will go down in aviation history as a most unique fighter bomber.